Hello and welcome back. So now that we have our lexer fully functional, let's go ahead and switch gears and start focusing on the parser. So over the next few videos, we're going to get a parser written, and we're going to kick things off with an introduction and some basic stuff like we did back with our lexer in the very first video, in that little sub-series, if you will. So Nelson, if you take just a second, talk about what it is we're going to be doing in this video here.
Okay, so like before, we're going to set up a base parser class. We're going to set up our custom parser class, and then we're going to stub out actually another set of classes that I call the parser test rig. And then we're going to write tests using that test rig. And the reason we need a set of classes to test the parser is that a parser is a lot more complex than a lexer, especially considering the language that we're working in. While the language we're working in isn't as quite complex as, well, a language like C#, it is complex enough to where expressing a test for it would be slightly difficult. Now, one of the reasons that makes that difficult is that we aren't actually going to be outputting to an AST. We are going to be invoking actions directly against what I call the builder interfaces, and we'll see what that means in a second because we're going to be stubbing those out too.
Okay.
And then finally, like I said, so we're going to build out our parser stubs and our test rig stubs and some tests.
Okay.
And everything should be good. So the purpose of our parser is to go ahead and establish meaning of tokens. So we get a bunch of tokens out of the lexer. And we already have this all functional. And we want to go ahead and find patterns within this output to sort of identify where things are going on. Because remember, the formatting right here is just for your benefit. In reality, there is no formatting in this token stream. It literally just is an ident followed by an O-curly followed by an indent and so on and so on. So our parser needs to sort of figure out, okay, well, am I currently looking at a selector? If I'm looking at a selector, is there a selector after the selector? And what happens when I hit a curly brace? Do I pop out of this and start parsing properties? How do I identify once properties are over? Do I find another closed curly brace and so on? So the kind of logic that's going to be in our parser is matching against patterns that it finds within our token stream.
Okay.
So yeah, so let me go ahead and switch over to Visual Studio into our CGS by hand solution. And I'm going to go ahead and start creating some classes or in interfaces and stuff. So I'm going to start with a base parser class, just like our lexer. This will contain a few different methods that will let us write cleaner parsers in the future. So it's going to be an abstract class, just like the lexer base class, and it's going to take in a lexer and a look-ahead count. And both of these are important to store. The look-ahead count is interesting because, unfortunately, not all language grammars can be determined by just knowing one token ahead. So we need to be able to look X number of tokens ahead, determined by our grammar and determined at compile time, to be able to parse this properly. And the implementation, how we're going to actually implement the look-ahead count is kind of interesting, but I'm not going to worry about actually writing that out just yet. So the next thing we're going to do is we're going to write a stub for our protected void consume method. Works just like our other consume method. Our protected token look ahead, which will look ahead X amount of characters. Our protected void match, which will take in a token type and match against that token type, just like our characters. And then finally, protected bool is EOS. So here's our quick stub, and we'll be filling in these methods in the video after the next video. Next, I'm going to go ahead and implement or stub out our CGS parser, which is going to be very simple. At least the stub will be very simple. It's going to take an lexer, and it's going to take in something else called an iStyleSheet builder. Then it's going to, well, of course, I have to tell it to inherit from our parser, or passer. We have a passer in this project.
I see that.
We want a parser. There we go. And then we're going to pass in our lexer and a lookahead count of 3 for now. And then we're going to store our builder out. Then we're going to have a public void parse method. And that's it, actually, for our stub. Everything else is just private methods, which I don't want to worry about stubbing out right now because how those private methods work is interesting enough to warrant its own discussion. So the next thing that we're going to do is going to go ahead and implement the iStyleSheet builder. Now remember how I said this parser isn't actually going to output a CS or a AST. It's going to actually invoke actions against my builder interfaces. And so basically that means that you can instantiate this parser, pass in a builder, and then the parser will invoke particular methods on the builder to build out a style sheet as it's being run. So it's just a way to genericize the kind of interaction between the parser and the rest of the environment. So I'm going to go ahead and add an interface called iStyleSheetBuilder to my abstract namespace, and it's going to have one method. Now remember that we have a style sheet, which is a collection of rules, and a rule is a collection of selectors and properties. Mm-hmm. So we're going to start out with one method in our style sheet builder called iRuleBuilder create rule. Now the iRuleBuilder interface is going to be pretty straightforward again. We're just going to have a method for iSelector. Oops, my cursor ran away from me. iSelectorBuilder create selector. And our void setProperty method, which takes in a string name and an IEnumerable of iValue. So next we're going to go ahead and build our iSelectorBuilder interface. And as you can guess, this is responsible for just, well, building a selector. And so building selectors are kind of straightforward once you know the terminology, and hopefully our intro covered what I'm about to show. But we're going to have void set class selector, string class, void set ID selector, string ID, void set element selector, string element. And then we're going to say push immediate descendant, I don't know, and then push any descendant. And then a void set, oh, I'm going to really embarrass myself with this. Let's just misspell it for now. I'll figure this out later once we actually get into the stuff. Okay, so now the iSelector builder. Remember that a selector can be multiple parts. Like you could have a class selector, then a ID selector, and so on. So what you would do to represent this with our selector builder interface is you would set the class selector. You'd push any descendant, because there is no greater than sign here, and then you'd set the ID selector. But the reason that I have the workflow this way is because you could also do something like h1.header. Now this is a combined selector of a element selector and a class selector. In that case, you wouldn't push either immediate descendant or push any descendant. You would just say set element selector, then set class selector. And that's how you would build out the selector that you want.
And if you want to update line 12 real quick, it's like PSE, and you do need to throw a D in there too.
Oh, wow.
All right. Yep.
Really? That looks weird. Maybe because I've been misspelling it in the actual code base so often. Wow, that looks bizarre. Anyway, hopefully IntelliSense will help me in this. So iValue. Now, when we set a property, we give it a name and a list of values. The reason you give it a list of values is because many CSS properties and CGS properties can take more than one value. For example, we can say padding 10 pixels, 5 pixels. This means give it a padding top and a padding bottom of 10, give it a padding left and a padding right of 5. Or we could say background equals blue, that's a bad example. We could say border 1 pixel solid black. That's another case where we have a number, an identifier, and a color. So that's why we need to support passing in multiple values. Values are represented with this iValue interface. And the iValue interface itself is only exists to be a step better than passing around objects because it has a property value type member, which is an enumeration. So this enumeration is pretty straightforward. We have different types of values. We have resources, strings, numbers, identifiers, and colors. So those are the different types of properties that can be supported. So that is almost it for this, except for we don't have any concrete value types implemented yet. Just make sure it builds, and it does build. So I'm actually going to go ahead and not worry about those until we actually get around to parsing out the value types that represent each one of these enumeration members. So this is actually it for our parser stub. It's all implemented as far as the public is aware, which means we can now build our test rig. And our test rig is really interesting because we need a very clear and concise syntax for expecting certain types of selectors, properties, rules, and all that stuff. So I'm going to go ahead and start by adding a namespace to my test project called base. And then I'm just going to create a class called parser test rig. And the parser test rig is going to take in a string input. It's going to have a few different methods on it as well. It's going to have a public void rule method that takes in an action and returns a rule configuration. Then we'll have a public void run method. Now, a rule configuration class will allow us to express rules in a little nice little DSL. This will make sense once we get into actually implementing the test. But for now, just bear with me. So basically, what we have to do is write a class that will allow us to express everything that a rule can expose. Which case is, first of all, we take in an itest rig like that, and we'll implement that second. We give a public void selector method, which takes in an action that takes in a selector configuration object. And then a public void property method that takes in a name and has params, iValue, array values. So let's go ahead and build our selector configuration class. So you'll see that this is starting to really mimic our builder classes, which is actually, you can think of these classes as the analog to our builder classes because they allow us to express what we expect to happen to our builder classes as our parser actually executes our code. So our selector configuration takes in an itest rig and has a public void class method, a public void ID method, public void element method, a public void immediate descendant method, a public void any descendant method, and a public void spseudo method. SEUDO. Okay, so that's all good. Now we can go ahead and implement our itest rig, or not implement, but build out our itest rig interface. And our itest rig interface is really only going to have one method on it called expect with iaction action. And an iaction is just going to be an interface that basically just requires that you implement equitable iaction. So anybody who implements this interface must make an equals method that accepts another iaction, because the only reason an action exists is to compare it to another action that might not be the same reference type. We'll see that in a second. So At this point, we should more or less build, except for we have to add some using statements. And to those of you paying attention, we do not actually implement the iTest rig here, so I'll go ahead and do that right here. And then I'll actually implement this explicitly so that publicly nobody has access to the expect method. So that is actually all we need to do, at least as our stub for our test rig.
Mm-hmm.
And we'll see in the future how this sort of fleshes out. But for now, this is pretty much all we need.
Okay, cool. So go ahead.
Yeah, I was going to go ahead and check out some tests first, though, using our stub using our test rig stub. So I'll write a parser test method or class, and I'll go ahead and write out some basic tests. So this will be public void parser given single rule executes proper actions. Start with the rig. Var rig equals new test rig. Parser test rig, sorry. Pass in the input, which is going to be test property string. Now this is where things get cool. To tell the rig that we are expecting our parser to invoke the methods required to create a rule, create a selector, create a property, and create a value. And to do that, we can use this cool little syntax that we basically just put together by doing rig.rule, r, then doing r.selector, s.class, test, r.property, test, and then our value, which will be a string value, which I will end up having to implement right now. So our string values are going to implement the I value interface. And basically all it's going to do is return out a string. And then it's going to take as a string called value, and it's going to be a public property. Finally, I'll also have to support equality members. So I'm going to have ReSharper generate some code for me. Pause this video right now if you do not have ReSharper and you haven't generated this code. So then finally, I'm going to go ahead and write a toString method that just actually prints out value. So I can say test new string value and say string. So basically this setup reads like this. Expect the parser to create a rule. Expect the parser to create a selector. Expect the parser to create a class selector. Expect the parser to create a property with the name of test and a value of new string value, or a value of string as a new string value. So this is a cool little syntax that we can use to test a lot of different things in our system. So moving forward, I'm going to go ahead and write a few more. There are a few things that we want to test individually, like pseudo selectors. Parser given selector with pseudo executes proper actions. And we're say rig equals new parser test rig, and it's basically just going to be test with the hover state with the test property of string. And then I'm just going to cheat and grab this stuff. And then my selector, I'm going to break this out into a multi-line because I also need to say the class is test and the pseudo is hover. So that's how we will test that the parser can handle pseudostates. Let's go ahead and add another test for resources. Resources are important, and they're kind of different than a lot of other things. So parser given property with resource executes proper actions. And I'm going to change this to resource property, and I'm going to change this to resource in parens. And then instead of a string value of string, well, first of all, this is going to be that. and the string value is going to be a resource value, which is going to be very similar to string value, but obviously has different semantics. So we're going to go ahead and write a resource value. Implements I-value, returns a resource, takes in a string resource, implements the equality operators. So again, pause the video if this is actually completely identical to the string one, except for we're using a different variable. And then we're going to add some formatting members because whenever we print out a resource, I want it to look like that. Okay, so now we have a resource value instead of a string value. And I just noticed that I did have a bug over here. This isn't text, or this isn't test, this is text property. And this isn't test, this is text property. So make sure to get that right. The next thing that is going to be, that we're going to work on with our parser is going to be number units. So let's go ahead and say, given numbers with units, executes proper actions. And I'm going to say things like property 1 is 4px, 5px, 1px, and then whoa is that px, and then test is 124.pt, and then we're going to make sure that all these properties are set. So the first thing that we have to do is actually implement our number value, otherwise we can't test this. So I'm going to go ahead and create our number value, which implements I-value, which returns a number, which takes in a float number as well as a number unit. Then I'm going to go ahead and write in the equality members. This will be a little bit different, so go ahead and copy this out if you don't have ReSharper installed. Then I'm going to go ahead and write my formatting. And my formatting is just going to be number, and then snuggled up against it is going to be unit. Now a number unit is going to be an enumeration that is either going to be px, pt, or none. So now my parser test for this is going to look like this. We're going to have property 1, new number value 4px, new number value 5px, new number value 1px. Then we're going to say r.property whoa, new number property 32.34 or 43 px. And then we're going, and then of course I have to add the f suffix. And then r.property test new number value 124 pt. Now there are some different things that we will be testing eventually, but I think this is enough to kind of get us started with a basic implementation of CSS, at least testing against class selectors, strings, resources, and numbers.
Okay.
So yeah, until the next video where we will actually go ahead and implement the test rig.
Okay. I just didn't want to say anything if you had anything else you were going to throw in there, and it sounded like you kind of did.
Oh, no. In the next video, we're going to be playing with the test rig, getting that to work, and the videos afterwards, we're going to be implementing our parser.
Okay. Fantastic. Well, with that, that is going to wrap up this video. Thanks a lot.